I'm Josh Detzel. I'm the founder and chief scientific officer with Cannabis Technologies, and I'm going to give you a presentation today about how nano-cannabinoids can enhance the performance of your active ingredient in edibles and beverages. Thanks for showing up today. Good to see all of you. Some of you I've seen at the booths over there. Let's get going. So as most of you are already aware, cannabis and hemp are two big growing markets in the U.S. In case anybody's not familiar, THC cannabis is legal in 38 states currently, 18 states are rec, 38 states medical, with in addition to that, Washington, D.C. and some of the outlying territories. Estimated market of $10 billion plus in 2022, with 15% growth rate estimated over the next 8 years. So quite a growing market, of course. Now, hemp, fully legal in 47 states. 3 states have some pretty severe restrictions, but those will probably lift here in the next year or two. Estimated market cap, $5 billion currently, a 21% projected annual growth rate up through 2030. So big market opportunity here. Now let's look at the forms that cannabis and hemp generally take. So predominantly, those are dry bud or flower, which is mostly used for smoking, and you can also make edibles with it, right? You have to do a kind of extraction of the active in oil typically before you do that. And then the more versatile of the two, which is extracts or distillates or even isolates. These are products produced by extracting the active ingredient out of typically the buds and sometimes other parts of the plant. This is where most of your edibles and your beverages and your vape cartridges, for example, are derived from, right? So let's look at smoking or vaping. Right? There's some serious benefits to smoking or vaping your THC or your CBD. First and foremost, efficient absorption. So you're essentially sending the active ingredient right into the lungs. It transfers to the bloodstream relatively efficiently, and you get a fast onset of action. And it's convenient. You can carry a vape around with you, and you can vape pretty much anywhere. Now, there's only one problem. There's a big social stigma against smoking. For example, in this facility here today, you can't vape or smoke your cannabis if you had some cannabis to smoke or vape or CBD products. There are also health concerns. Every year, fewer people are up for smoking due to the public campaigns against smoking and the health concerns associated with it. Furthermore, there are some dosing difficulties with smoking. So it's difficult to deliver a precise amount of cannabinoid in most vapes today. Your exact dose could vary depending on how charged your battery is, whether your pods are leaking, or how long you held down the button for, essentially. So there's a lot of pros, but some serious cons to smoking or vaping. So let's look at eating. Everybody here is probably familiar with edibles. CBD or THC edibles are very prevalent at this particular show and in the marketplace. Now, the pros are everybody's used to eating. If we weren't, we wouldn't be here today, right? You have to eat to survive. So there's no social stigma, and it's a relatively easy way to administer the product, albeit maybe a little bit more difficult than vaping. It's harder to carry around a brownie in your pocket with you. But there are some serious cons that go along with eating your cannabinoids as well. One of those is the slow onset of action. So anybody who's tried an edible knows it may be an hour or two before you feel the peak effects of the dose you consume. And occasionally, people will consume more looking for the effect, and then they consume too much and they'll swear off edibles for years because they had a bad experience. So there's that. And then there's inconsistent dosing. So if you're consuming an edible, how much THC or CBD your body actually absorbs is heavily dependent on when you ate your last meal, what the fat content of your last meal was. And so absorption can range from as little as 5 all the way up to perhaps 30%, consuming cannabis or hemp orally in food products. And then there's the first pass metabolism issue. So I don't know who here, if you could raise your hand, who's familiar with 11-hydroxy metabolite of THC? So one of the big issues with consuming THC orally in foods is a lot of it is routed through the portal vein directly to the liver. So before it hits your bloodstream, it gets metabolized by the liver into what's called 11-hydroxy metabolite. The high that you get from the 11-hydroxy metabolite is different in kind from a high that you would get from the THC just making it directly to your bloodstream. And it's not a high that many recreational users are necessarily looking for. So there are some serious improvements to be had with edibles as well, of course. Now let's look at drinking, right? We've seen cannabis and hemp beverages here today. Raise your hand if you've seen a booth promoting cannabis or hemp beverages. All right. So easy administration, no social stigma. You can drink a shot. It's easy to carry with you. You can drink a soda, you can drink the water. But there are some formulation difficulties that make beverages difficult to produce. The main reason for that is cannabis compounds, specifically CBD and THC, and the distillates and extracts that contain them, are oily, for lack of a better term. The scientific term for it is hydrophobic, or water-fearing. So the molecular bond character of these molecules is very different from that of water. And probably all beverages are predominantly water. Water and oil don't mix, as we know. So it's difficult to take, for example, a THC distillate and incorporate it into a water-based beverage and have it stay stable for a long period of time on the shelf until your consumer picks it up and opens it up and consumes it. Even if you could get the two to mix, and you can do this with some conventional emulsion technologies, you're not going to get the same level of absorption that you could get with some of the more advanced technologies that I'm going to discuss here in a minute. Even if you can get the cannabis into the beverage, you're still going to have the same issues as you would with eating, which would be the first pass metabolism, the inconsistent dosing, and the poor bioavailability. Now, there is a solution to all of this, and the solution is nano. So with good, high-quality nano, we call it top-tier nano, you can produce clear, stable, fast-acting beverages that are highly bioavailable, and you can produce consistently dosed, fast-acting, highly bioavailable foods like gummies and other products, of course. The only caveat here is nano is really only applicable in products that are water-based or based on mostly hydrophilic ingredients. So anything that's based on water, sugars, gelatin, those kinds of products, even baked goods where water goes into the recipe, those are all great applications for nano. And chocolate or something like that would not be a great application for nano, just FYI. So what is nano? Well, in the context of this presentation, we're talking about mostly delivering cannabinoids. Though this technology can be used to deliver any number of oily or hydrophobic bioactives that aren't absorbed well by the body. So a lot of our clients are actually processing kava extract as well, and there are a lot of other applications, omega-3s, vitamins, you name it. But for all of these applications, including cannabis, we're talking about oil in water nanoemulsions. So as you can see in this graphic here, we've got, I'll just point, the laser's not working, we've got a nanoparticle suspended in a water matrix. So the water is the continuous phase, and then you've got a hydrophobic core, which is composed of your lipids, typically they're long-chain triglycerides or medium-chain triglycerides, and your active ingredient, CBD or THC in this example. And then you've got your surfactant layer surrounding the oily core, bridging the gap, if you will, between the oil and the water. And these surfactants, they're called amphiphilic molecules. They have sections that are both hydrophilic and sections that are hydrophobic. So the hydrophobic section will embed itself into the oily core, and the hydrophilic section will be exposed to the water, making the oil and the water happily coexist together, essentially. And then there's one more criteria for nano. If we're using the loosest definition, nano must have a particle size below 1,000 nanometers. In other words, your particles have to be on the nano scale to call it the product nano, obviously. Now, I'll show you in a second why it's better to have smaller particles. So, top tier nano versus inferior nano, that's a topic that we discuss a lot with our clients. If you've been out in the market, and I'm sure all of you have, there are a lot of companies repping nano products, beverages, gummies, etc. And there's a big difference in quality between top tier nano and inferior nano. I would estimate from what we've seen, and we have the ability to size particles at our lab, maybe 75, 80% of what's out there is inferior quality nano. And I would say only 5% or so meets the strict definition and checks all the boxes for top tier. So what are you looking for? Well, you would want a verified particle size under 100 nanometers. Even more ideally, you'd want that particle size to be under 50 nanometers to take advantage of all the bioavailability gains that you can have from nano and all the clarity gains in a beverage, right? But even under 100 nanometers, you're still going to have a stable product that goes into a beverage, doesn't separate over time, typically, if it's well formulated, and does enhance bioavailability. Now, you'd want stability. I just touched on that, but there's something called kinetic stability. So if you can get your particle size down small enough, and usually that's substantially below 200 nanometers, the emulsions are essentially self-stirring. So the nanoparticles essentially get stirred by the Brownian motion and the convection currents in the beverage, and so you'll never see separation on the shelf. So that's how you produce a stable product. And then if we check these two boxes off, to really have a top-tier product, we want it to be acceptable to the widest variety of consumers and retailers. So you'd want it to be clean label and composed entirely of food-safe grass ingredients. And by clean label, I mean no polysorbates. Now let's look at Inferior Nano. Like I said, our estimation is maybe 70% of the product, 80% of the product out there on the market falls in this category. Inferior Nano typically has a particle size between 200 and 1,000 nanometers, and truth be told, we've seen some horror stories in our lab. We've gotten product that clocked in around 3,000 nanometers in the past, and we've gotten product that wasn't even nano that was marketed as such. In other words, it was just oil-based, cannabinoid solution, right? Yeah, so 200 to 1,000 is typically what you see with lower quality nano. You're not going to get your clarity. You're going to leave a lot of your bioavailability on the table, and you're not going to have your kinetic stability. So in these types of products, you might have to stir them or shake them before you consume them. And if you're lucky, you're not going to have issues with the material sticking to the container. Oftentimes you do, though. So like I just touched on, these lack kinetic stability, they stick to containers. And thirdly, some of the inferior quality nano that we see is clean label, but much of it is not. And is anybody here familiar with like Whole Foods ingredient requirements or any regional health food chains that are similar? There are certain ingredients that they have on a list where they will not carry a product that contains those ingredients. One of those ingredients, one of the worst offenders, is polysorbate 80. Polysorbate 80 is a really common surfactant, and it's technically food grade, but it's fairly synthetic, and there are a lot of health concerns around its use in products. So a lot of these inferior quality nano products, they're based around polysorbate 80 surfactant. And then some of the ones we've seen included surfactants that were not even grass. So we're talking about cosmetic grade ingredients. That's a little more rare, but you have to watch out with certain companies. Anyway, so let's talk about particle size and bioavailability. I've touched on it a couple times throughout this presentation already. Generally, the smaller, for a given formulation, for a given active, holding all of that constant, the smaller you can get those particles, the faster it's going to absorb and the more completely it's going to absorb by the body. So this is a study done on a drug called cyclosporin, and this study is really interesting because they formulated the same drug into different nano-emulsions with varying particle size from 400 nanometers all the way down to 25 nanometers. So even though this study was not done on CBD or THC, the trends are conserved with CBD and THC, at least grossly, right? So you can see that at 400 nanometers, the area under this curve, the lowest curve, which corresponds to the body's total absorption of the drug or the cannabinoid in question, is relatively low. If we could calculate that area, let's say that area is just 1, for example. Now, if we look at the same drug formulated into an emulsion at, say, 200 nanometers rather than 400, you can see we're talking about this curve here. And let's say just nominally that area is 2. So you've already got a twofold enhancement, roughly, in total absorption by going from 400 to 200 nanometers. Now, if we drop down to 60 nanometers, we see a nearly doubling of the area under the curve again. So you can see there's huge gains to be had going from 200 or 400 nanometers all the way up to down to 60 rather. And you can see the gains kind of diminish. So you still see improvement as you approach 25 nanometers of particle size. And you're definitely going to see improvements in terms of product clarity, for sure. So perceived product quality will improve because the clarity improves. But you're getting most of your bioavailability around 50 nanometers or so, would be my assertion. That's why we kind of set the threshold for top tier nano at ideally 50 nanometers or less in particle size. And as you can see, if you've got inferior nano, you're leaving a lot on the table. So there we go. Now, you guys might be asking, how do you produce top tier nano or nano in general? There are predominantly three methods used. There's high shear mixing, there's high pressure homogenization, and then there's ultrasonic processing. So we'll go through each of these three methods. High shear mixing is relatively inexpensive. These high shear mixers run maybe between $5,000 and $15,000, depending on which mixer you purchase. And they can get you down under 1,000 nanometers with the right formulation. But it's very, very rare that they'll get you under about 200 nanometers. So high shear mixing is out if you want top tier nano. And a lot of companies currently producing nano products in the market, this is the tech they use. So high pressure homogenization is the second method we'll talk about here. Who's familiar with a company called Anybody? They're a West Coast outfit, well-funded, well-advertised. They produce nano for cannabis processors to produce retail products with. Anyway, they use, last I checked, I should caveat that, they use high-pressure homogenization. And HPH will get you maybe under 100 nanometers, but not too far under 100. It won't get you below 50. At least we've never seen a product produced with HPH get below 50. And furthermore, I have a background in pharmaceutical development. When I worked in pharma, we used these machines, and we have a lot of clients who have used these machines in the past. The upfront capital cost for these machines relative to their throughput is ridiculous. They're very expensive, and these are not solid-state devices. So you actually have a pneumatically driven piston moving at a very high rate of speed at ridiculously high pressures, generating the shear force in these machines, and in my experience, they're a reliability nightmare. So service contracts are a must, and they're not cheap. So if you want the best nano, I would recommend ultrasonic processing. We can achieve particle sizes as low as 20 nanometers reliably with ultrasonic processing. And what's cool about it is it's a solid-state process, meaning there are no physical moving parts in the ultrasonic processor. There are vibrating parts, but there's no mechanical motion at play. So you get reliability and you get predictability. So there are consumable components in the ultrasonic processing system. Those would be the ultrasonic horn predominantly, and then the filters if we're talking about the whole process, right? But at least the horns have a known lifespan and they're relatively inexpensive to replace. So in terms of running costs and upfront capital costs and product quality, there's no question about it. Ultrasonic processing is the way to go if you're after top tier nano. Now, we do offer ultrasonic liquid processors. This system here pictured is a 2,000 watt system. They're generally, I'll just explain how the process works, right? How this setup works. So you would typically take your surfactant, or you could use a surfactant that's commercially available, like our Nano Optimizer. You would blend it with your active ingredient, and then you would heat it up, mix it, add water, and then you would load that material into this process tank. When the system's running, this magnetic drive pump is circulating the material from the process tank through our ultrasonic reactor chamber, which is connected to our 2,000 watt ultrasonic power supply. So you've got anywhere from 1,200 to perhaps 1,500 watts of ultrasonic energy being input into this emulsion. And it's generating what are called cavitation bubbles. These are, when something moves through water so fast that the water can't keep up, a vacuum is formed. And that vacuum is unstable, and it wants to collapse. So when that vacuum collapses, it collapses asymmetrically, and it forms what's called a microjet. So we're talking about little, almost supersonic jets of water. And those jets of water are what hit the particles and explode them, essentially. So it hits a particle, breaks it up, And if you keep doing this, you get down smaller and smaller and smaller in terms of particle size. So once you've processed your batch, the clarity will increase dramatically. So you'll start with something that looks like eggnog, and you'll end with something that looks like almost like a maple syrup, depending on what the terpene content is in your distillate, right? Maybe a light maple syrup. So when you're done, you would just switch over to filtration. And our systems are equipped with a pharma-grade 200 nanometer absolute rated filter. And what comes out the other end is totally clean nano, typically with an average particle size between 25 and 35 nanometers. And you're ready to infuse your beverages, your shots, your gummies, your mouth sprays, even your topicals. I didn't touch on topicals yet, but that's another application where nano is very effective. So I mentioned our surfactant system, Nano Optimizer. With our equipment systems, or with any ultrasonic system, of course you can develop your own surfactant. You can use things like lecithins, you can use things like Q Natural, which is a saponin solution. And those are great natural surfactants, but they won't get you down that small in particle size. You could also use highly synthetic blends with polysorbate 80s, maybe some PEG 400. But if you're after something that performs better than any of those options and is clean label, Nano Optimizer is a good bet. So, we spent a couple years developing this product, and you simply blend it with your THC. It contains all of the carrier oils, the antioxidants, the surfactants, and the preservatives necessary to produce these emulsions in a turnkey fashion. And you can see here we have a particle size distribution graph of an emulsion made with Nano Optimizer. This particular emulsion has a volume-weighted average particle size around 30 nanometers, and you can see that effectively all of the material is below 100 nanometers, so it offers near perfect clarity in a beverage product, and it also offers maximum bioavailability. And then I'll conclude with the difference is clear. The quickest, easiest way to tell whether your nano that you're looking at has a good particle size or not is by the clarity in something like water in a clear container. So if you've got something with a 200 nanometer particle size, it's going to look pretty cloudy because it's going to scatter visible light. And if you've got something like the products that you can produce with our system with closer to a 25 nanometer particle size, it's not going to scatter visible light. It's going to look nearly entirely transparent. And so in the middle, we've included so these are dilute solutions, 15 milligrams per mil, and then here is 15 milligrams per container on the sides. And then in the center here, we have a nano emulsion concentrate. This is like what you would get directly out of the machine. And this is at 33 milligrams per mil of CBD content. So you can use this to dose your beverages, your gummies, etc. And then I'll open it up to questions. Anybody have any questions?
Yeah. Okay, so you mentioned that the CBD, the actual CBD is oily. Is that the cured oil that's causing the oil, or is it the actual product that's out of the hemp?
Yeah, that's a good question. So even something like CBD isolate, if you look at the molecule itself, it's a very hydrophobic molecule. So even though it's oily is kind of a simple way to say it, and I apologize if that was confusing a little bit. You could have even something like a powdered CBD isolate, snow white, free-flowing powder, and the compound itself that constitutes that material is hydrophobic still, and it's not really water soluble. Hydrophobic means water hating or water fearing. The molecular bond character of a compound determines what it's soluble in and what it's not soluble in, basically. So the more polarity, the greater the charge asymmetry in a molecule, like water, for example, the more hydrophilic it generally is. And if you don't have a lot of charge asymmetry around your compound, like CBD or THC, for example, then those compounds don't typically dissolve well into things like water. So even though it doesn't feel or seem oily, I just use oily as a surrogate for hydrophobic, basically. Any other questions? All right, guys. Well, thank you. Appreciate you attending. You can visit us over at what is it, Alex? 1757, just over there. If you want to know more, or if you want to watch a video on how our system operates, we've got a quick 7-minute video. Goes over the entire process. Have a good day.